Hello everyone, in this video it is required to compute the integral x squared plus 3x plus 7, and then we have a complex expression on the denominator. Well, the easiest way to approach kind of problems is express this expression in total into partial fractions. So to do this, we assume that x squared plus 3x plus 7 is divided by x plus 1, and then we have an x squared plus 2 all squared would be equals to a, then we have x plus 1. So this is the numerator corresponding to x plus 1. We will also have bx plus c, and then we have x squared plus 2. This is x squared. Then we have a cx plus d, and then all divided by x squared plus 2 all squared. Now the next thing is to multiply both sides by this denominator. So we'll be having x squared plus 3x plus our 7 being equal to a. A will have the factor x squared plus 2 all squared. Bx plus c combined together will have the factor of x squared plus 2 and also the factor of x plus 1. And then we have a cx plus d would have the factor of just x plus 1. Now the next approach here is to get at least, we either set x to be equal to 0 or x equals to 1 or negative 1. We just want what will make this expression here vanish. Well, this case, the simplest case is when x is negative 1, where these guys vanish all together. So the correct approach now, what we're going to do is that we set x equals to negative 1. This case, this will have 1 minus 2 minus 3. So 1 minus 3 plus a 7 being equals to 1 plus 2 is 3, all squared is 9, so that is 9a. And notice that both of these guys, they vanish all together. So that will give us that 9a is equals to 5, because 1 minus 2 is negative, 1 minus 3 is negative 2. So that means that a would be 5 over 9. Now, having gotten a, the next approach for us is what I call the complex numbers approach, the complex numbers method. For this case here, notice that here we set s equals to negative 1 because we know that s equals to negative 1 is what's going to make this guy vanish as well. But now we have a factor of s squared plus 2, s squared plus 2. So if we can eliminate this factor of s squared plus 2, then we are going to be halfway through solving the problem. But the issue then is that what will make s squared plus 2 equals to 0 is when x is square root of 2i. And yes, we are going to set x to be square root of 2i, and then we are going to simplify according to the laws of complex numbers, because this equation is an algebraic equation that is true for all values of s, both real and complex. So we don't really need to just put only for the real values. We can as well go for that and put for complex values as well. So we'll just make some rearrangements. Let's flip over to the next page. So we'll have that x squared plus 3x plus our 7 being equals to a had the factor of x squared plus 2 all squared. Then bx plus c had the factor of x plus 1 and x squared plus 2. Then dx plus e, dx plus e had the factor of just x plus 1. So what we'll do is that we let x to be square root of 2i. So when we say x to be square root of 2i, this x squared will be negative 2 plus, this is negative 2 plus 3 root 2i, then plus our 7 being equals to, this will vanish, obviously, this will vanish as well. So we are left with d, like d root 2i plus e. Then we are having root 2i plus 1 as well. Now this will be 5 plus 3 root 2i being equals to, now this, multiplying this, we are getting negative 2d, and then that would be plus square root of 2i times d. Then we have plus square root of 2i times e plus e. So we are going to still put 5 plus 3 root 2i to be equals to, that will be e minus 2d on one part, then we'll have plus square root of 2I, then we'll have d plus e. Now we're going to compare the real and imaginary parts. So real and imaginary parts of these two expressions. Once that comparison is made, we are going to have that e minus 2d would be equals to 5, because the real part of the left hand side is 5, so everything here will be equal to 5, and then d plus e will be 3. Okay, no, this is 5. Now what we'll do is we're going to subtract. So when the subtraction is done, that means negative 3d will be equals to 2, or that d would be negative 2 over 3. That means that e would be 3 minus 3 plus 2 over 3. Yeah, 3 plus 2 over 3, that would be 9 plus 1, that is 11 over 3. So e will be 11 over 3. So let's move over to the next board. So we have this expression, which is x squared plus 3x plus our 7 b equals to a of x squared plus 2 all squared plus bx plus c, and we're having x squared plus 2, then x plus 1, and then we're having that dx plus e is just x plus 1 multiply. Then we are already found values of a being negative, being 5 over 9. We already found e and d. Let's check the values once more. E was 11 over 3, so, and d is negative 2 over 3, I believe. Yeah, so d is negative 2 over 3 and e was 11 over 3. So let's see if we can find b and c. Well, the quickest way we can do this to set s to be equals to 0. This case here, these terms vanish. Then we'll have 7 to be equal to 4a. Then we'll have 0, c, b goes to 0, so we'll have c alone. But this is 2c, so that is plus 2c. What do we have here? This e, only e survives here, plus e. So that means that e would have to be equals to, this means that e would have to be equals to 7 minus 4a minus 2c. Now 4a would definitely give us 7 minus, this will be 20 over 9 minus 2c, c, right? Okay, no, we don't know e, we know c only. Okay, we know e, but we don't know c. Okay, I'll have to just let me see. I think there's a slight mistake from here. We are looking for c actually. So what I'll do is that I'll write okay, so 2c would be equals to 7 minus 4a minus e. 7 minus 4a minus e, so that would be 7 minus 20 over 9 plus minus 11 over 3. So everything adds up to, that will be 10 over 9. So we'll have a 10 over 9 here. So everything adds up to 10 over 9. That means c itself would be 5 over 9. So have a new member in the family, c being equals to 5 over 9. So all that we need to do, the only thing we left us to is to find b. Okay, let's just set x equals to 1. That will help us find b. So let x be 1. I'll do it in a different color. So let's see, if x is 1, that means this is 4 plus 7, that is 11. 11 would be equal to, this is 1, this is 9a, that is 9a. Then this will be b plus c. This is 1, that is 2 times, this is 3 times 2, that is 6. So that is 6 times b plus c, plus 6 times b plus c. So that would be 2d plus e, plus 2d plus e. Now our goal is to get out what b is. So that means 6, this means that 6b plus c would be 11 minus 9a would be 5, obviously. So 11 minus 5 plus 2, what is d plus e? D plus e added up together will give us 9 over 3. That's 9 over 3 is 9 over 3 is supposed to be, okay, 11 over 3 minus 2 over 3 is 9 over 3. That would be 3. So when we are going to subtract 2d plus c, that is 11 minus 5. Okay, that is supposed to be minus here. So that would be minus 2 times 3, that is minus 6. Yeah. So 11 minus 6 is 5. Let me see. Okay, so 11 minus 6 is 5. Then minus 5 is 0. So this tells us that 6b plus c should be equals to. So that means that 6b plus c should be equals to 0. Right? So that means that b is equal to negative c. And what is our c? 5 over 9. So therefore b is negative 5 over 9. Now let us go back. Okay, let's see our problem here. The integral of okay, this expression x squared plus 3x plus 7 being equal all divided by x plus 1. Then we'll have our x squared plus 2 all squared. So this is equals to a over x plus 1 plus bx plus c over x squared plus 2, then plus dx plus e all divided by x squared plus 2 all squared. Therefore this integral of x squared plus 3x plus our 7 all divided by x plus 1 and then x squared plus 2 all squared would be equals to a would be 5 over 9, right? So that is 5 over 9 times the integral of dx of x plus 1 plus b and c are equal, we are told. So that would be b, that is negative 5 over 9. That is, instead of minus, I have negative 5 over 9. Let me be sure. Okay. Yeah, so that is 5 over 9. So that is negative 5 over 9 times the integral of x plus 1 x. Yes. Yeah, no. I think one of them is negative. B was supposed to be negative, right? B was supposed to be negative. So that is x minus 1 instead. So that is x minus 1. So that is not a x minus 1 over x squared plus 2. And what is d here? D is negative 2 over 3. While c is 5 over 9. E is 11 over 3. So that is same thing as negative 1 over 3. That is integral of 2x minus 11 all divided by x squared plus 2 all squared. Let me be sure. C E is 11 over, yeah, E is 11 over 3. So what do we do next here? Here obviously this result is easy to write down. This is 5 over 9 times the logarithm of x plus 1. What about this integral? Well, you can separate this integral into two forms plus, let's say, other integrals, and let's evaluate them one by one. This 5 over 9 dx, this integral, first of all, we have 5 over 9 times x dx over x squared plus 2 plus 5 over 9 times the integral of dx over x squared plus 2. Now this will be easy peasy because the first case here, now we can multiply the numerator here by 2 and divide by 2. So that would be the logarithm 2 over 18 times the logarithm of x squared over 2, x squared plus 2. So that this one is easy. Then this case here, now this is plus 5 over 9 times 1 over root 2 tan inverse of x over root 2. So this is also easy. Now what do we have? The last integral, that is 2x minus 11 over x squared plus 2. So our last integral is the integral of 2x minus 11 over x squared plus 2 all squared. How do we do this? Well, we can obviously separate it into the integral of 2x dx. Okay, that's the dx here. 2x dx. Then we'll have all divided by x squared plus 2 all squared minus 11 times the integral of dx all divided by x squared plus 2 all squared. How do we evaluate this part here? This is just negative. This is negative 1 over x squared plus 2. Yeah, because if you integrate it, if you differentiate this expression, that's what you get. Because you can always set u to be x squared plus 2, then du would be 2x dx. So this integral is basically integrating du over u squared. This is negative 1 over u. That is why I got this expression. You can always do this mentally in your head. So what about the second, this part here? Well, to find the integral of dx over x squared plus 2 all squared, this is what we'll do. We'll let p to be 2x over x squared plus 2. Now dp dx is x squared plus 2 all squared. Now 2x, the derivative of 2x is 2, so 2 times x squared plus 2 minus 2x minus 4x squared. That would be 4. This will be equals to 4 minus 2x squared, right? Yeah, so that will be 4 minus 2x squared all over x squared plus 2. So I can always write dp over dx to be equals to how do I group it now? I want to write this will be equals to half of negative 1 over 2 times 2x squared times x squared minus 4 plus 2 minus 2 all divided by x squared plus 2 all squared. So I forgot to write the square here. So this will be equals to negative 1 over 2 times 1 over x squared plus 2. Yep. Then this will be that will be negative minus 1 over 2. That will be negative 6 over x squared plus 2 all squared. So that will be 1 over 2, 1 over x squared plus 2 here. Then we are going to have plus 3 over x squared plus 2 all squared. So let me go to the next board. Okay. Alright, so what we'll have is that dp dx will be negative 1 over x squared plus 2, I believe. So that is negative 1 over 2 x squared plus 2. So that is negative 1 over 2 x squared plus 2 plus 3 over x squared plus 2 all squared, where p is 2x over x squared plus 2. Now how do we find p? Well, how do we get the integral we need? If you integrate both sides, you get that p is equals to the integral negative 1 over 2 times the integral of dx all divided by x squared plus 2 plus 3 times the integral of dx all divided by x squared plus 2 all squared. Notice that this is the integral we need though. So therefore the integral of dx over x squared plus 2 all squared is equals to p. What is p? That is 2x over x squared plus 2 minus this. So that will be plus 1 over 2 times the integral. So wait, this is 1 over 2 times the integral of dx over x squared plus 2. So that would be 2x over x squared plus 2 plus 1 over 2 root 2 tan inverse of x over root 2 plus c. So we have already integrated all the terms coming out of this expression. Let's see. We already did this integration, did this integration. So you can just put them together and you get your final value. So thank you for watching, and please do subscribe to the channel. Thanks and have a nice day.